Assalamu alaikum students, this is Farwa Batul, your O-level computer science instructor, and welcome to another video. Since we have started activity 10.4 of chapter number 10 Boolean logic, so in this video we will be doing question number 2. Question number 1 is already done, part A, B, C, D, E. So you can watch the previous videos to understand question number 1. Now quickly moving towards question number 2. The question says that produce the logic circuit and complete the truth table. Look here. And the truth table to represent the following scenario. A chemical process is protected by a logic circuit. There are three inputs to the logic circuit representing key parameters. So it means you can easily see that the number of inputs we have in the logic circuit are three, and that are basically the key parameters in the chemical process. An alarm X will give an output value of 1. It is very important. X is basically your output of the logic circuit, and its value 1 depends on certain conditions in the chemical process. The following table describes the process conditions being monitored. So what you have to monitor, look at this table. These are the parameter descriptions, parameter binary values, and the description of conditions. So as described above, that there are three inputs to the logic circuit. So here you can see that number 1 is R. Parameter R is your chemical reaction rate that you have to observe. Second is your T, process temperature. This is also that is you have to monitor. Then concentration of chemicals, which is C. So these are the three input parameters, and the values of these input parameters can be 0 or 1. These are the binary values. Either R can be 0 or R can be 1. Same goes for T and same goes for C concentration. And remember that if R is 0, it means that reaction rate is less than 40. So every value has a meaning. If the value of R is 1, it means reaction rate is greater than equals to 40. Same for temperature. You can see that if it is 0, it means temperature is greater than 115, and if it is 1, temperature is less than equals to 115. For concentration, if C is 0, it means concentration is less than equals to 4, and if it is 1, it means concentration is greater than 4. So the values of R, T, and C are specifying some condition. Okay, so now quickly moving towards the next important thing. Okay, so let's read an alarm X, which is your output, will generate the value 1 if. Now look at these conditions. All of these conditions are going to help us in producing logic circuit. Okay, so output 1 will become X will have a value 1 if reaction rate is less than 40 either, or concentration greater than 4 mol and temperature greater than 115. If this will be 1, this whole, or the third condition is if reaction rate is greater than equals to 40 and temperature is greater than 115. So you can see that there are three different conditions. If any one of this condition becomes 1 or true, then your output will become 1. So let's just quickly convert all of these conditions into a logic expression. So the first thing we have to do in this example is produce a logic expression out of these given conditions. So logic expression will be produced by using these conditions. So the first condition is either reaction rate is less than 40 mol. Okay, reaction rate means it is referring the first parameter, that is R. And it says that reaction rate is less than 40. And when you see your table, let me just erase all of this. Okay, if you see the table, then reaction rate less than 40 means that the value of R in this case is 0. And remember that when the input parameter is 0 or having a binary value 0, then you will write it as not R in your logic expression. And when it has a value 1, then you will write it as R. Same goes for temperature. If the temperature value is 0, then you will represent it as not T in the logic expression. Otherwise, if it is 1, then you will represent it with T. And same goes for concentration. Not C when its value is 0 and C when its value is 1. So in the first case, reaction rate is less than 40, which means R equals to 0. And when R is equal to 0, we can simply write the logic expression here for the first condition is not R. And then we will put a bracket into it. This is our first condition that needs to be true in order to have our output value x true. So we make it x equals to. Now look at this. There is an or between these three conditions. So we will be writing or and then our next condition. Bracket. Bracket is going to help us to differentiate the three conditions. Okay. Or concentration is greater than 4 mol. Look at this. Concentration greater than 4 mol means concentration, it is over here, which means that C has a value 1. So you will write C as it is. Then after that you can see an AND operator. It means that two conditions needs to be true simultaneously. So we will write AND, and then this other condition is temperature must be greater than 115. If you see your table, temperature greater than 115 means that must have a value 0. And if it is 0, then we will represent it with not T. So I will write it not T. Then my second condition is closed in the bracket. Now look at your above description. The third thing is there is an or, and there is or between these three conditions. So again, I am going to put or here, and then my third condition will be in the bracket. Okay, so for the third condition, look at here. Reaction rate greater than 40. Go to R. See, when reaction rate is greater than equals to 40, it means that value of R will be 1. So we can simply write R in the logic expression. Then there is AND. So we will write AND because again two conditions are must be 1 together in order to have your output 1. So R AND temperature is greater than 115. Again, it means that T must be 0. And for T must be 0, you will simply write it not T in the logic expression. This is how you are going to write down the logic expression for the given example. Now I am going to move towards the first part of the question. The question says that you have to produce a logic circuit. So let me produce the logic circuit first and then we will go towards the truth table. Okay, so it's very easy. In order to produce a logic circuit, you have to consider the input brackets first. 1, 2, 3. So let's start with the first one. The first one is not R. It means that your input R, this is R, this is going to be passed through an inverter in order to give me not R. Okay, so the next thing is C and not T. So now I will make a line for C and then I will make another line for T. But in my expression, T is inverted. So I will pass T through an inverter just like R. Okay. Now when it is passed through an inverter, I will get not T. Now look at this, not T and C are both going through an AND gate. So I will pass both of these lines through a AND gate, through an AND gate. So the result of the AND gate will be C and not T. So we are done with the second bracket. Now quickly moving towards the third bracket, which says that R and not T, which means I will be taking R as an input, and with R I have to take not T. So I can take a line from here. Since I have already passed T through a NOT gate in my previous, like for my previous bracket, so I can use the same line of NOT T in this case. So NOT T and R are going to pass through another AND gate, so that I will have, here I'm going to have R and not T. So finally, I got three of my inputs, three of my brackets. First one is not R, second one is C and not T, and third one is R and not T. Now, if I need to find out the result, look at this. All of these three brackets ha are having OR gate between them. It means that this is a binary addition between them. So the simplest way of finding out the result is to pass all of these three input lines through an OR gate. You can have a 3-input OR gate. So I will be making a 3-input OR gate which is going to accept 3 inputs. The first one is not R, the second one is C and not T, and third one is R and not T. So it will produce an OR operation between all of these 3 input lines, and then the final result will be X. So it is an OR gate with 3 inputs. So finally, the value of X will be, let me quickly write it here for you. X equals to, first one is not R. This is the first input of your OR gate. Then it is getting OR with the second input, that is C and not T. And it is getting OR. All of these three are getting OR, or having a binary addition. This one. So this is your final logic circuit for the given example. Now the first part is done. The logic expression we have already produced. Now quickly moving towards the truth table. So look at this. I have already produced the truth table. I will just paste it over here. Okay, so this is the truth table that I have produced in MS Excel. I just shared it now, and I can just quickly explain you that what are the columns for this particular logic expression that I have made in the truth table. So the first first three columns are your input parameters, R, T, and C. One is for rate, other one for temperature, and C for concentration. Then you see, after your input parameters, you are going to see the logic expression and find out that how many of these parameters are being inverted. So here I can see that R is inverted, has a not with it, and T, temperature, is being inverted. So I will make two columns for them. One column is not R and the other column is not T. there is no need to make two columns for not t because both are going to have the same values. So we will just invert the values of t in order to find out not t. So once you are done with this, then you will see your inner brackets and you will find out the values of those. So the first inner bracket was not r, that was already covered in the truth table, so I haven't made another column for it. The first bracket was not R, I have already done with it. Then not T, and the second bracket was C and not T, which is over here, C and not T. And the third bracket was R and not T, which is over here, the the next column. Now, the final result will be this one when you are going to do an OR operation between all of these three input brackets. So let's start the working. Let me just erase these arrows to make it clear for you. The first thing you have to fill are the values of your input parameters. And remember that if you have three input parameters, then there is going to be 8 input combinations for your binary data. So let's quickly make that. For C, it will be 4 zeros and 4 ones. For T, it will be 00, 11, 00, 11. For R, it is going to be 4 zeros. Sorry. Oh, I did one mistake. I'm really sorry. You have to start with 010101. This is something we can say that it is a practice, a general practice to fill the binary combinations like this. So the first, the C is going to be 01010101, then T will be 2 zeros, 2 ones, 2 zeros, 2 ones, and then R is going to be 4 zeros and 4 ones. This is basically in terms of the power of 2. 2 ki power 0 means 2 raised to the power 0 is 1. It means we are inverting the values. 1 times 0, 1 time 1, 1 times 0, 1 time 1. Then it is 2 raised to the power 1, which is 2. It means we will have 2 zeros, 2 ones, 2 zeros, 2 ones. And the third will be 2 raised to the power 2, which is 4. It means we are going to have 4 zeros, 4 ones. And if we have 4 input parameters, then the column next to it, before it, will have 2 raised to the power 3, which is 6. It will be having 6 zeros, 6 ones, 6 zeros, 6 ones. So it is like that. Oh, sorry, it's 8. It means 8 zeros, 8 ones, 8 zeros, 8 ones. So I hope that you are getting my point. This is how you have to fill your input parameters to make all of these combinations different from each other. So next is not R. Not R is very simple. You have to invert the values of R. It becomes 1 1 1 1 0 0 0 0. Inversion means that whenever you have 0, you will make it 1, and whenever it is 1, you will make it 0. This is called inverter, inversion of your input parameter. Okay. Then you have not t. Not t means that the values of t are going to be inverted. So it is 2 zeros, 2 ones. We will make it 2 ones, 2 zeros, 2 ones, 2 zeros. So this is finally done. Now quickly moving towards our third column, that is C and not T. C and not T means that you will consider the column of C and the column of not T, and you will be producing AND operation between them. It means AND operation is nothing but the multiplication of these binary bits. 0 into 1 is 0, 1 into 1 is 1, 0 into 0 is 0, 1 into 0 is 0, 0 into 1 is 0, 1 into 1 is 1, 0 into 0 is 0, 1 into 0 is 0. So we are done with this C and not T, the binary multiplication. Next, we have R and not T. R and not T means that you will be considering, let me just quickly erase these dots. And let me tell you that what we have to consider now for R and not T. So the column we will consider is the column R and column not T. And this time we will be doing binary multiplication between these two columns. So it is 0 into 1 is 0. Then 0 into 1 is another 0. Then 0 into 0 is 0. Then 0 into 0 is 0. Then 1 into 1 is 1. 1 into 1 is 1. Then 1 into 0 is 0. Then 1 into 0 is 0. So we are done with this column as well. Now quickly erase these dots and let's find out the result, the value of x. And for the value of x, you have to consider three columns. The first will be not R, which is over here. The second is C and not T, which is this one, C and not T. And the last column we need to consider is R and not T. And what needs to be done with these three columns is binary addition. Look at this. There is OR operation between all of them. So we will do binary addition between these values. So let's do that. 1, 0, 0. I can simply write 1 plus 0 is 1. It's binary addition. 1, 1, 0. 1 plus 1 plus 0 will give you 1. Because remember that in binary addition, you can only represent 1 plus 1 with 1. Because either you have 1 or you have 0. So if your answer is 1 plus 1, in basic maths, 1 plus 1 is 2. But in binary addition, 1 plus 1 is also 1 because you have only two digits to represent your data, 1 or 0. So it is not 0, it cannot be 0, it can be something. So it is 1 in binary data. Then next is 1, 0, 0. 1 plus 0 plus 0 equals to 1. Next we have 1, 0, 0. Again, 1 plus 0 plus 0 is 1. 0 plus 0 plus 1 plus 0 plus 1. Remember that if any of these columns has a value 1, then your output is going to be 1 because this is what the description of the logic circuit says. 0, 1, 1, that if any one of these conditions becomes true, then your result will be true. 0, 0, 0. Yes, this is the case when your alarm is not going to produce any sound because the output is 0. 0, 0, 0. Another condition where the output is going to be 0. So this is how you have to fill the truth table for this particular example. I hope that all of these things are understandable to you. And if you have any questions, you can comment below. In the next video, we are going to start another important question, and that is question number 3. So stay tuned, stay connected, and do not forget to subscribe the channel. Bye bye.